Welcome to this tutorial on pre-processor scripting in Flexcom. My name is Angus Connolly and I'm the product manager for Flexcom software. In the previous tutorial I showed you how to create a range of regular wave analysis of different periods in different directions. So in this tutorial I'm going to focus more on a random C excitation, which is characterized in terms of a scatter diagram. So let me just quickly look at the scatter diagram first before we begin. So in Excel, or you normally have these. They come from Mid-Ocean data reports. You'll have a series of ranges of wave amplitude, significant wave height, HS in this case, in feet, and that's on the vertical axis. And then on the horizontal axis, we have a series of TZ, or mean upcrossing period values. So there are quite a number of different seastate combinations, and even this scatter diagram is relatively simple. So what I've done is I've just reorganize these into a vertical format. So for the various combinations of HS and TZ, I've just taken out the value of occurrences, and I've reformatted this scatter diagram into just a series of columns. You can write a little script to that for yourself in Excel or VBA. So what Flexcom does then is we can read in all these different combinations of HS and TZ directly from a Flexcom keyword file, from Excel into the Flexcom keyword file, and I'll show you how to do that. So let me switch back to Flexcom for a moment. This is the one we were looking at previously, the regular wave simulation. So I'll just go in here and I might just start from scratch. Actually, I'll just do a brand new keyword file. It might be easier for us to see. So I'm just going to call this one random C template. It's a metric keyword file as usual. I like working in metric. And perhaps I'll just clear this. I'll clear some of these old directories away. I don't really need any of the old files now. Clean directory deletes a lot of files, and I'll also just delete these regular wave folders which are not of interest to me right now. Okay, so now I'm in the random C template. I've cleared everything. So the first thing to do would be to define a load case as normal. Define a random wave seastate excitation, so Pearson-Moskowitz with an equal area discretization. HS and TZ, I'll actually just define some parameters for HS and TZ now before I go any further. So I'll do that in the pre-processing section. Add in two parameters, one for HS and one for TZ. The values you specify aren't actually that important because they'll get overwritten by the values that we read in from Excel anyway. So I'll just set these just to 1 and 1, just to initialize them. In terms of the wave itself, then I'm going to reference the HS and the TZ as the amplitude, the height, and the period. Then I just need to set the number of harmonics. So normally it can be 100 harmonics to discretize the wave spectrum. We can cover the theory in that in some other tutorial. It would be a unidirectional wave with a dominant direction of 0 degrees. So I would also need to say what the analysis type is. Obviously it's a dynamic, time-domain dynamic analysis. I would need to define some time variables. So I normally use a variable time step, start at 0 seconds. Typically I might run for 3-hour simulation. So I'll put down 10,800 seconds here, although I won't perform this simulation during the tutorial because it would take some time to run. Ramp time of 100 seconds. Suggested time step, let's just say 0.1 seconds. It's quite a small minimum, and let's say the maximum is about 0.1 as well. I would also need to restart this dynamic simulation from the previous one, which would be the static file here, which was the static equilibrium configuration for this steep S riser that we were looking at previously. So now I've got a load case set up for a single Pearson-Moskowitz wave, but obviously we want more than that. We want to have a separate simulation for every combination in the seastate scatter diagram, which we have defined here. So let me define some more variables up here. I'll just begin by defining a parameter for the case, which is just a number. Set that to 1 just to initialize it. I already have my HS and TZ variables. What I might like to do as well is just to format these nicely. So I'll call case string. This will just take the case variable and add some more text to it. So you can concatenate strings in this fashion as well. So I'm going to concatenate the word case with a neatly formatted 2-digit string for case itself. So let me just do that. So now if we look at case, it's the number 1, which we can hover over. It's just the number 1. If we hover over this one, it's case 01 in that text format. So that's just nice for renaming files and putting them into easily readable format for Explorer. So I'll do the same thing for HS. I'll just copy. The easiest thing is just for me to copy this text here, and I'll put this HS. And if I want to format HS, it would be more of a decimal format, so I'd have like sort of 14.2 or whatever it would be. I'll have two digits before and 1 digit after the decimal, and I can copy that format again for the final one, which is my TZ, my crossing period. And just need to change this one to TZ as well. So now I have all the variables I need. So the final step really then is just to define how they vary. So this is where we link Flexcom to Excel. So you might recall in the previous tutorial we used parameters and then variations to vary those parameters in fixed increments. Now we're just going to use it. We've already used the parameters keyword, so now we're going to read the variations for those parameters directly from Excel using the Excel variations keyword. So there are some options here. Let's say the directory, we'll just maybe create a new directory called random C. That'll be the folder name. You don't really need a subdirectory. We do need a file name. This is quite important for to name the files. We can just use the values that we have already defined up here. Then let's say we can have the file name would be the case string, which is something like case 01, and then maybe in brackets afterwards we might want to put in our HS and TZ character expressions. So start off with the HS1, and then obviously the TZ. And because I'm referencing parameters, parameters which are part of the preprocessor section, within the preprocessor section, I've got to use these percent symbols just to tell Flexcom I'm referencing predefined parameters here in this preprocessor section. So that defines the file name. That's what the generated file will be called. Now I define the source, which is the name of the Excel sheet itself. In this case it's called scatter diagram. I'll just copy that in here. Now it's looking for a worksheet name. That is sheet 1, I believe. And then the range, this is the range of cells, which again is important. I'll just get that from the Excel sheet. So the first number I'm looking for is N3, and I go all the way down to P43, so it's N3 to P43, and that's all I need, I think. Orientation is horizontal. It's a column layout. So let me just run the random C template and let me see what happens in terms of variations. So we'll just wait for a moment or two while Flexcom lifts the data from Excel and starts to generate these additional files based on this random C template master file that I've generated. There's a little error here, no parameter data, so let me just check the Excel spreadsheet again. So the range of cells, oh, I now realize my mistake. So I started off at N3, which is this row here. I really need to start off at N2 because I need the column titles as well, because Flexcom uses these column titles to identify the variable names. So I just need to go back and edit my inputs. This was N2 to P43, and it should run successfully now. Let's just wait for that to work. So it's hopefully looping through the Excel data. My laptop is not the quickest laptop, so it may take longer to run than a more higher spec machine. So you can see it's running along fine there. Inside here we now have, I'll just close this so we can see that a little bit bigger, make the file view a little bit bigger. So in this random C folder now, which is brand new, it has been generated from this random C template input file, and it now contains 41 different C states. So if I just pick, you can see they're all nicely named. They've got case, number, HS and TZ, all really clear. If you double click on this one, we see that the HS does indeed correspond to 5.6 feet, and a TZ of 8 seconds. So if we were to run this simulation ourselves, which I won't do now because these are random C simulations which run for 3 hours, they would take quite a while to run, but it's all set up totally for you to do your run later on. So you can just right click on that folder and you can go run all analysis for all these files when you go home from work in the evening, or to do an overnight run. But it just shows you how very, very easy it is to set up all this in Flexcom. What we can also do as well at this stage, maybe we look at that in a subsequent tutorial, is really, I haven't actually added any post-processing in here, but I could add some, for example, some summary post-processing, and I could look at statistics of effective tension or bending moment in any of those simulations, pick out so that it produce a summary file, and then which summarizes the maximum and minimum values, either measured or statistical extremes, and then we could collate all that data into one central spreadsheet using the summary collate function. That's for another tutorial, I think. So we now have covered regular wave variations and random C variations in terms of keyword file generation using preprocessor scripting within Flexcom. So I hope you found these last tutorials quite useful. They certainly should be able to expedite you as you create your load case variations within Flexcom itself. You could always do this stuff yourself using scripting like Python scripting or other means as well, but this is how you do it from within the Flexcom software itself. So we can just leave it at that for this tutorial, and I look forward to you joining me for other tutorials, more advanced tutorials further down the line.